Central Oregon Irrigation District began in 1900 with the posting of water rights on the Deschutes River near Bend, Oregon. The farmers in the area needed water to improve their crop yield, and by banding together they were able to create irrigation canals. The district now serves 3,600 locations, channeling water from the Deschutes River through canals to farms raising livestock and forage crops on otherwise arid land. The canals were built by hand with teams of mules and crude scrapers. The land was cleared to rock and soil was mounded into berms to create waterways. The canals, essentially wide shallow depressions with porous lava bottoms, lose significant water due to seepage during the 6-month irrigation season. Sladen was awarded an engineer-procure-construct contract for the Juniper Ridge Hydroelectric Project on the basis of competitive proposals. Sladen's combination of experience, financial capacity, and willingness to commit the necessary resources to the project were seen as the best value option for the district. The project was shovel-ready, so additional federal funding was available, but only if the project could be started and completed in a short time. The project was built inside the existing canal right-of-way. The purpose of the canal is irrigation, but by harnessing the elevation drop, the district is able to create clean energy. Creatively, the project uses the Federal Energy Regulatory Commission's so-called conduit exemption. Because the nature and character of the water is the same after passing through the power plant, the district's original irrigation water right can be used to produce hydropower. Use of the conduit exemption significantly reduced and simplified permitting. The district has the largest senior water right on the Deschutes River, so it takes more water than other users. Replacing the unlined canal with a pipeline not only increases the flow and reduces seepage into subterranean lava, it allows hydroelectric power to be created. There are also important environmental benefits in taking less water. It improves fish habitat for threatened salmon and steelhead runs and allows more and better downstream irrigation and recreational uses of the river. Once it was awarded the project, Sladen not only had to complete a design but also secure the necessary permits and get long lead time equipment ordered. An amendment to the land use zoning was necessary to allow hydro on what had previously been zoned for park use. Immediately after the groundbreaking of the project, blasting began. The blasted rock was excavated and transported to a crushing and screening facility owned and operated by a local contractor. The rock was crushed and graded and then returned to the pipeline right away to be used for bedding and backfill on-site. The pipe manufacturer was a local Oregon company. Because of the short time frame of the project, the order for pipe was made before final design was complete. Relying on the early order, the pipe supplier was able to secure a slot in the steel plant schedule so that they would have the raw material to make the pipe in time to meet the strict time limits of the job. The pipe manufacturer worked 7 days a week fabricating the pipe so it could be delivered to the job site just in time for installation in the ditch where full joint welding and painting took place. Irrigation is done in the summer. Pipe laying, construction of the headworks, and construction of a bypass at the power plant had to be finished during the winter so there would be no interruption of irrigation water. At the same time the pipeline was being installed, design of the turbine, generator, powerhouse, and associated buildings and machinery was taking place. Because of the long lead time for equipment, it had to be ordered before a final design was complete. In order to allow design and construction to efficiently take place, building information modeling, or BIM, techniques were utilized. The pipeline entry into the powerhouse and the location of the turbine and generator were modeled in 3 dimensions to allow designers and construction personnel to visualize the relative size and orientation of the components. The resulting efficiencies in scheduling of components to the site, design of forms, which were fabricated off-site, and installation of the mechanical and electrical components allowed the project to be completed on time. Sladen's lean construction techniques, including using BIM concepts for planning, pre-ordering of long lead time materials, and just-in-time delivery of construction components and equipment, worked well on this very restricted site. The right-of-way was long and narrow, with only one public road access. In addition, Sladen had to work around the railroad right-of-way and keep railroad traffic running. The specialized turbine and generators were manufactured in Ohio and had a lead time of over 12 months. Logistics were finally coordinated so everything was delivered in time and it all fit together. Sladen is an Oregon company with headquarters only 2 hours away from the project site. Unemployment quadrupled in Central Oregon during the year immediately before the job started. Over 16% of local workers were without jobs. So, in addition to designing, permitting, and building the facility, Sladen took it upon itself to maximize the project's positive effect on the local economy. The project was 100% made in America. Sladen hired local workers, contracted with local subcontractors and suppliers, bought tools and materials locally, used local motels and restaurants, and generally did all it could to leverage the cost of the project into local pockets and maximize the local multiplier effect of project spending. Safety is an important part of Sladen's culture. Sladen has one of the best safety records in the construction industry. Money saved through safe operations is given back to the workers in the form of incentives, special trips and outings, and recreational offerings for the entire family. The Juniper Ridge project was built without any lost time accidents or major safety incidents.